Okay, so good afternoon, everyone. My name is Michel Botman. Welcome to this presentation of OTF Connects titled Using Math Moment to Multiply Math Skills. Today's episode is called Make Math Moments Through Analyzing Data and Probability with our star presenters, Carl Pearce and John Orr. And so as we were just mentioning, it's already episode 8 in a series of 10. It looks like we started yesterday, but yeah, the series is progressing and we're coming slowly to the end. As I was mentioning, we actually have 139 people registered for this session today, which is a bit less than we had last week. Last week we had about 160 people registered. And as I was also mentioning, I fear that we are fighting a mighty Canadian opponent today called spring weather, or at least spring-like weather, because here in Toronto, it was absolutely fantastic today. And I just came back from a walk in the ravine behind my house with my dog, and it was packed with people. The paths were packed with people. So I hope that teachers are going to make it back on time to join us for this session number 8 of our math webinars. I know it's hard to fight Canadian weather in the middle of winter, like spring weather in the middle of winter. So it's going to be challenging. But anyway, we're going to do our best. So let me start with our usual land acknowledgement that OTF is asking us to read. We acknowledge that we are gathered in the territories of various indigenous people, and we further recognize their stewardships of these lands in which we live, learn, work, and play. And as I say, we have our 2-star presenters. Thanks, Carl and John, to be with us again for this series of webinars. And since you are pretty much all return participants, I can see familiar faces and familiar names. I'm not going to insult Carl and John by reading their bios, since they are so well known in the province already. So all I'm going to do is invite you to visit their blogs. Carl has 2 blogs, tapintoteensmind.com and mathisvisual.com. And John has 2 blogs as well, called MrOrisAGeek.com and mathbeforebed.com. And if you visit these websites, these blogs, you will have access to all the resources that they have to share with us, and their podcast, etc., etc. So at this point, John, I'm going to invite you to jump in and take over. And I hope we're going to get a few more participants. I'm hopeful. Fingers crossed.
I'm sure, Michelle, they will trickle in. So thanks again, as always, for that intro. And we are always proud and excited to join you folks here on Thursday afternoons, going into Thursday evening. And we're excited to get going on this, being episode 8 out of 10. And going to talk today about data management in the probability strand, and how you can spark curiosity with that and fuel sense making. Hey Kyle, it's a strand that gets overlooked resource wise, whereas I think there's a lot of resources out there on the session we described last week on proportional relationships, and lots of folks talking about fractions and other resources. If you're, say, Googling resources, you are always left going, what do I do with data management, and how do I teach that? So we're going to get started in that. Kyle, let's talk about what we're going to get out of this session.
Absolutely. And before I want to kind of segue and kind of connect to what you just said there, John, is, this idea of data management and probability tends to, especially in elementary, we don't see it a whole lot in secondary until later in the years, which is kind of interesting. If you look at the way the curriculum is set up, we see it every year in elementary. But then all of a sudden we get into grade 9 and 10. It's not really looked at a whole lot. There's a lot of graphing that goes on. But then in grade 11 college, we start bringing it back. And then also in grade 12, we have an actual data management and probability course. So there's like this big gaping hole in the curriculum. And what I find is that educators, especially when speaking with elementary educators, we tend to do some of this stuff either at the beginning of the year, thinking like, there's not a whole lot of substance there, so it's a nice, easy way into the curriculum. On the other hand, sometimes people save it till the end and they think, last few days of school, we'll just try to like get as much done as we possibly can, right? So I think what I'm hoping we can do today is actually help you see some value. John, I'm going to like jump kind of backwards or kind of start in the middle and work our way out on the what you'll get.
Sure.
But when we talk about investigating data management and probability, not only can we look at it conceptually, but I also want you to kind of think about how you can use data management as potentially one of those areas that you can elicit other big ideas and bring it into. It's almost like using this concept, using this strand as a means to explore some of the other strands and give you a kind of like an excuse to re-explore it. So that's going to be one of the things we're going to try to emerge here. John, as usual, what else are we going to try to do as we get into the math today?
Yeah, before we do the next one, I'm going to ask Michel to stop sharing his screen. And then I'm going to pin you to the front of the screen, Kyle, to just to kind of get everything rolling here.
Yes.
One more thing on your end, Kyle. We see this black bar at the top. I think your camera is angled up just a little too high. Tip it down just a little bit. There we go. And then we'll see exactly what we need to see. Perfect stuff there.
All right.
Very good. You're good now. But yeah, let's get into the next two. What you'll get if you're joining us repeated. This is not your first session that we love to give you or let you know what you're going to learn. But these next two are the two that we've had ongoing for every single episode, which is we would hope that we can spark your curiosity here today, following the curiosity path, so that you can do that with your own students. So that you can get their curiosity. It's only through that curiosity we feel that you can get true buy-in and learning with our students. Kyle, what else are we going to learn here today?
Awesome. And always top of mind for us when we're working with educators and when we're working with students is continuing to find ways to repair or strengthen the relationship with mathematics that we might have. And, I've worked in a lot of different classrooms over these last 4 years in this consulting role with my district. I get an opportunity to go into grade 1 classes, into grade 8 classes, into grade 12 classes. I get to go across the curriculum. And when I do, I notice that it doesn't matter how young students are. There are always some students that have had, we'll say, maybe a couple blemishes on their relationship with mathematics. So that's one of the big ideas here that we're hoping to do. We know we have a lot of teacher candidates with us here. We have a lot of newer teachers or NTIP teachers, and also maybe just some teachers that may just want to be looking at mathematics a little bit differently. So that's one of our big piece here. We want to build your productive struggle so that you can help build productive struggle in your students. So John, today we're going to be diving in. We're going to try to spark some curiosity, just like we've done in these past sessions. And I'm actually getting a little bit sad that pretty soon we're not going to be doing this on Thursdays with many of the same friends. So today I'm really hoping that we can dive into a task and do a bunch of great sharing together.
Yeah, for sure. And this being episode 8, we got 10 to do. We got 2 more after this. So really looking forward to those 2, but looking forward to today as well. Kyle, let's we're going to kind of, I don't think, as I said, Michel said he noticed that most people here are returning. Give us, if you haven't yet gotten yourself in the chat, let us know where you're coming from. Yep. Let us know all of that good stuff. Also the idea of like how many sessions you've been to, because I think we got a lot of returners. I don't know if we need to go into too much about the idea of sparking curiosity so that we can fuel sense making. I think we could jump right into the task we've got set up to get going.
Awesome. And I'm really excited too, because we're going to be looking at another task, which actually comes out of a unit. And I'm hoping that we can explore 2 different parts of this unit. And then you're going to have to obviously explore the remainder on your own. We'll give you a link so that you can be sent off to do some of that. So we're going to start with a notice and wonder like we have in many of these previous episodes. And what we're going to have you do is watch this very short video clip. And this time we are going to have you sharing, just keeping it coming into the chat. And actually, John, I'm going to encourage folks to raise a digital hand if they even want to like turn their mic on and share some noticing and wondering. The audio is pretty much just like ambient noise. So there's really not a whole lot to listen to. So it'd be great to hear some voices out there of people just kind of turning their mic on and sharing some of these, noticing some of these wonders, just to kind of get this this conversation going here.
Yeah, we're in a smaller group. We got 30 in the room right now. So we're in a smaller group than we have in the past. So definitely, I think it'd be fine to switch on your mic, folks, and just wonder out loud and see how that goes. It would be great to hear some voices come in as Kyle plays. So right now on his screen, he's got Notice and Wonder. I'm going to pin him up on the big screen. We're going to spotlight for everybody. There we go. And so he's going to hit play here in a moment. You're just going to notice. You're just going to wonder out loud. Feel free to type in the chat, but we want to hear some voices. All right. Already? Here we go. Kyle, take it away.
All right, let's check it out.
Oh, I see Kyle.
Are those Tootsie Rolls?
Saltwater taffy.
Here they come the voices.
I love it. I love it.
I love it.
Turn that mic on. Turn that mic on. What are you thinking? What are you noticing? What are you wondering? I'm going to play it again. I noticed it was 507.
Oh,
Wondering how many different colors there are.
Ooh.
How many altogether?
I'm wondering if it's summertime.
There's a bag.
And what are the flavors? And is it Halloween
flavors.
candy?
Oh, I love
Could
it.
be
I'm going to try
Halloween.
to,
It could be Halloween. Could be.
I'm going to try to jot some of these. So how many flavors?
Colton wonders if it's his daughter. I wonder if it was summertime. She's
Nice
pretty
kitchen.
cold.
I'm having flashbacks to when those
good
necklaces were
countertops.
popular.
I was thinking the same thing. I'm like, that's such a cool kitchen. I want that kitchen.
Awesome stuff, folks. And Kyle's typing those out. And just if this is your first session here with us, if we're doing this in class, and it looks like most of us, well, I don't know, I shouldn't say most of us, but Kyle and I are both going to be back in the classroom on Monday. But that's different. I guess the Toronto area is still going to be out for another week, but we're going to be back in the class. And if I'm back in the class, I'm writing these up on the board, jotting them down. Usually I have my students write them on the boards first, or jot them down wherever they are first. And then I'm recording them up on the board, putting names on it. We've talked about that in past episodes as well. We're not going to go too much into detail about recording noticings and wonderings and making it, inviting this nice atmosphere into your room by making kids' voices heard. All right, Kyle, we've got some notices. We got some wonders. We're wondering colors. We're wondering flavors. We got some
I'm
Halloween.
missing some here. I don't know if there was some others that we can toss in.
How about the ingredients, right? Like what's it made of?
Could you change my how many colors? I mean, how many colors of like each?
how many of
So we've got like how many colors, but then it's like how many of each color.
Right. Yes. Thank you.
Got it. Yeah. No sweat. Awesome. We've got lots of good ones going on here. We have some coming in the chat. Yeah, Annabelle was saying the same thing. Like, how many of each color? Does she get to? Does she have to share, or can she keep them all herself? That would be something that I think that any child would be thinking, and maybe an adult as well. I mean, I would definitely like to have some. Where did she get them from?
Is that the total amount, or did she hide some? That's a small sample size.
Ooh, super cool.
Right.
Total, or did she?
We got Sarah saying, "Is it fair to share? Like, is it a fair to share amount? Like, is it going to be nicely enough to share?" Tanya is starting to predict mathy stuff. Are we going to do a graph? And kids will start to try to like guess what math is involved. Is this fractions, sir? Is this, instead of saying noticings and wonderings, they kind of like, it's like, where's the math involved? That's not a bad thing, right? If kids are starting to develop some connection towards the math that's coming, welcome that for sure, because that's where problem solving is happening, right? That's like that strengthening of connections to previous math learned. Lots of good notices, lots of good wonders, lots of wonders this time for sure.
I know. I love it.
Are
I
they-
love it.
Are they soft or hard candies?
Soft or hard. Nice
Mhm.
job. And you know, a lot of these too. I was in a class about 3 times over this past week and a half. And it's like by the 3rd time I was in this class, it was like we had just tons of wonders happening. Like people kind of stopped with the noticing. But when you do have something where there's something really interesting there, there's something that they've noticed that's kind of hidden, then they start to really focus in the notice as well. So lots of really good stuff going on here. Annabelle's got it going on here. Proportionate share based on age. Like I'm thinking about when you think about that, proportionate based on age would be such an interesting problem. And again, another data issue for us to maybe draw on, right? Like this weighted mean idea is like something that kind of pops into my mind from an educator standpoint. So lots of really.
Do we get to eat the candy?
Do
We'll
you
send
get
them
to?
out.
Yes, exactly. We're going to send it out over Zoom. It's actually Michelle's going to be mailing them out, right?
I know.
It's 4D Zoom.
Kids
I
would be
noticed-
wondering if we get to eat the candy.
Yeah,
That's what kids are going to
exactly.
say. Did you bring us some?
Exactly. And you know what? All the time. And it's great when we're in regular times, like nowadays, right now, you can't share food, you can't bring food in, all that stuff. Once we're back in class, I know some districts are back already. John and my district are not back yet. We're going back on Monday. But even then, it's like some of the things that we could do in, we'll say, usual times aren't happening in the same way. But there's a lot of fun that can be had here. John, I've got like tons of notices, tons of wonders here. A few that we might want to like knock off right away off this list. I'm going to do one and then I'm going to let you pick one, John, and you can try to like answer it if you feel good. Was it Halloween? The answer is no, it was not Halloween. I'm going to leave it at that for now. And then I think I have more to share about that later. John, what's another one that we can maybe knock off the list?
I don't know if we can knock off how many flavors, because I think that leads into some of the thinking we're going to do today.
Yeah,
But
and I can't even really tell from
and also how many of each color. Like I think color and flavor are going to go hand in hand here, is my guess. And the total. I think the total. I don't know. I think we could work towards something there, Kyle. Like this is also like. As I've mentioned this in past episodes too, is that we often in class will go through the wonders and start to write down, okay, what's got a quantitative answer? Can we star the ones with quantitative answers? Because we'll explore in depth there and we'll narrow down our list to say, hey, how many flavors? That's got a quantitative answer. Was it Halloween? No, but maybe that's the one you can answer, right? So how many candies? That's a quantitative answer. We should star that one. We can explore that one. And then once you have this narrowed down list, you can then go, okay, let's look at this particular problem that we're going to focus on. And keep this in mind, folks. I don't know if how clear, I feel like we've been pretty clear on this, Kyle, but the idea that Kyle and I know exactly what question we're going to work on here. And I think we've glossed over that a little bit at times. It's that this isn't like we're just going to go wherever the kids propose. It's very clear which task what we've set out, and we're just going to make sure that either that one comes out, which is up there, but otherwise we add it and we make sure we go that route and then come back and answer questions later. But Kyle, are you ready?
I am ready, John. I think what we're going to start, and it does connect to some of these wonders here. Some people were asking like how many of each color. So let's get started there. But as we typically do when we're following the curiosity path, we like to, of course, withhold information. And we like to build some anticipation. And how I'm going to build some anticipation with you is by asking you to kind of go out on a little bit of a limb here. And we're going to have you estimate how many candies you believe to be in that bag. Now, some of you might be thinking, oh, I wish I was paying more attention to that when the candies were all out on the counter, because that was there. And now that we're in a digital world, you can imagine some students might start screenshotting when you do this sort of thing, because they know that they might have to go back and kind of think a little bit. But I'm going to have you look here, and we're going to have you start with a little bit of an estimate of how many are in the bag. And then when you share that back, I'm gonna help you out. I'm gonna give you a little bit of information and also a little more context. I told you it wasn't Halloween. These candies are actually from a scenario or an event that I'd like to tell you a little story about in just a moment. So we're gonna give you a little bit of time to think on that.
Mm-hmm.
And John, I don't know, did you want to pop up Braining Camp and pop some of these down, and we can keep people accountable? We also didn't give any instructions on how we're going to share. So John, go ahead and you can share your screen, get yourself all set up. I'll manage the chat here. And remember from last time and some of our previous episodes, sometimes we'll have you hold back and we'll have you hold back from sharing until everyone's had some time. Today, we didn't do that. So we've got a lot of estimates up in the chat. So as John gets himself queued up here, I'm going to start having a look into the chat. And something I'm noticing is I'm noticing in the chat that a lot of these estimates are actually pretty tight. They're pretty close together. And I find that as we go through the grades, as we get a little bit older, a little more experienced with our counting and quantity skills and our spatial reasoning, those estimates tend to get tighter and tighter. But if you're in a really young class, if you're in like a primary class, you might notice that it would be much wider because there's such a variance of experience with counting and quantities. So that's just for you to think about. If you're like a JI teacher getting prepped for JI, not JI, for PJ, for primary junior, you might notice that range is like actually quite wide here. John, are you ready to get us some of these? I'm going to give you a couple of the low end estimates, if that's okay to start.
Yeah, give me one, the highest you ever saw, just so I can set my scale here while I'm working digitally.
Highest I've seen is 36. That's the highest.
So let me put this at 40, and then let me go grab one. And you said 36?
Yes.
So we'll drop one there at 36, and then I don't know. Let's go with a name on the highest here.
And John, I just want to mention, because I think it's worth sharing. Sarah, if you're not watching the chat, Sarah says she likes asking kindergarten kids how old they think they are, or they think you are as the teacher. It's usually somewhere between 7 and 1,000,000,003. So
1,000,000,003. Nice.
I really like that, and I would agree that sounds right on par. Elizabeth, we are using Braining Camp, brainingcamp.org. And Elizabeth, if you shoot me an email, because you're a part of Greater Essex, I will get you hooked up with a license. For those who are interested here, I think they have 30 days up on their website right now. Sometimes they do 3 months when they do
I think you
webinars.
can actually get 90 days. They got webinars that are running now. I think when I went to, hang on, when I'll just a notice, they've got a webinar going on, what's the date today? Feb 4th, Feb 9th. And I know that when they run webinars, they give out like 90-day licenses or longer for folks that show up. We ran a webinar for them last spring, and that's the one that we gave up. Okay, I went away, so I need to reset my.
Oh no! Look what you've done. Okay, so 36 was the high there, John.
Yeah, let's do that. Let's get that one.
Some of the lows. I'm going to give you some lows as well. I think 12 is our lowest.
Give me a low. Give me a 12 is low. Okay, give me some more.
I'm seeing lots in the 20s. So like I see 22. From Colton, Sarah's got 25, Patrice 27, Dora 25, Nicole 25, Tanya 25, like lots of 25s. I feel like that's definitely our mode.
25
here.
And look at this. We can make this. I'm gonna just change the.
It's almost like a little bar graph you're creating.
You caught on, right? This is a good idea for this. You can, if I got more, I can drag these down if they're spaced out proportionally here. Let me drag that down just in case there's another 25 kicking around. Give me a couple more, Kyle.
Yeah. I got a couple 32s there. Like Ness and Annabelle were saying 32. Sharon had
32s?
22.
All right.
Yep.
Let me get 2 32s in there and another.
Anna's
22.
got 20.
A 20. All right. We got a 20 in here.
Savi, I hope I'm pronouncing that correctly. Savi has 30.
Yeah, you got it. Thanks.
Awesome. And think about this, folks, as I organize these in this very particular way, is that think about just estimation problems in general and visually demonstrating it on the number line, how I've done it here, how it connects to, say, the data management pieces of our courses, depending on no matter what grade level you could be doing this. And say bringing that idea out, like think about like I'm almost like starting to build a box and whisker plot. We're kind of, get in. Kyle already talked about the mode, but we can definitely talk about mean, median, mode just from estimation problems alone.
Interesting. I'm loving it. Awesome stuff. Well, okay, so here's the thing. So we've got you estimating, we've got some accountability in my classroom. I'm going to make sure like we're tossing those names down, and we're going to try to, keep that nice and organized, make sure that students, so we can come back and actually celebrate those students who came pretty close to the estimates. Super cool stuff. But now I want to give you a little bit. So John's going to keep this in his tab. We can come back to this in a little bit. And I'm hoping that we might be able to get a little bit closer here. But in order to do that, I actually am going to need to do a little bit of work on my end. And what I mean by that is I'm actually going to be telling you a little bit about how this bag of candies came to be, okay? Because actually it wasn't from Halloween. A few people were saying Halloween. Maybe some other people are thinking like maybe Christmas time. This was actually a birthday party. All right. This was for Talia's birthday party. Now I'm going to take a moment and I'm going to step to the side here. I'm telling the class it's Talia's birthday, my daughter, but actually in reality, you get to make up that part of the context. Okay. So in reality, you get to decide what the context is. But for us, it would be Talia. And you're going to see on the screen, it's actually a girl named Lucia. It's her birthday party. And she actually invited her friends over for a scavenger hunt. Okay. And when they were going around, basically they had different stations set up. So they had to go to these different stations and they had to do different activities in order to collect a certain amount of candy. So the better you did in the station, the better you did for collecting the candy. All right. So that's the context of what's going to be going on here. However, here's the problem. In order for us to figure out like how many candies there were in total, the information, this is the only information we actually had. Okay. Like one of the friends' names was Chin. Chin collected about twice as much candy as Lucia. Okay. So Lucia's the birthday girl. Again, you could swap out the name. I could have put Talia there. I could put Landon or whoever I want and make the story match in my classroom. So Chin collected about twice as much candy as Lucia did. All right. Now, here's the thing. James actually collected about 1.5 times as much candy as Lucia.
Okay.
And 3/4 as much candy as Chin. Okay, so I'm going to let that sink in here. I'm not going to take this off the screen yet, but if you don't already have a piece of paper yet,
right.
you're going to want to definitely have a piece of paper ready, or a digital whiteboard, or whatever it is that you're using. Some were using whiteboard with an eraser. Feel free, whatever you choose. All right, so we've got a little bit of information here. I do have a little bit more information. Savannah, another friend, collected about 1/3 as much candy as James. Yikes. And I think this is my last friend. Marquis collected about 1 1/3 as much candy as James.
Okay.
Last friend. Hader collected about 3 times as much as Savannah did.
Interesting.
Okay, so we've got a lot of action going on here. Now, here's the challenge I have for you. And this is the challenge we would have for our students here today, is that before I give you anything else, I want you to create some sort of visual, maybe it's a graphical representation, to help compare the quantity of candy collected by each participant. So now as the teacher, we're going to put our teacher hat on here. And actually, John, I'm going to flip it to you, like putting your teacher hat on, and you're looking at what we've given. What are some of the things that we have given? And then I guess like what's still left for us to kind of like still stay in estimation land? Like, I don't know if you've picked up on that, or if anybody else in the room's picked up on that and they want to share.
Let's open it up to the floor here for a sec.
What do you think, friends? Like, what's going on? We had you make an estimate, and we're still.
So we estimated how many were in the bag, and I guess, Kyle, I wonder if here's a wonder. Now, I don't know if this is the wonder that any of you are having. Like, there's a couple of wonders happening in the chat right now that aren't related exactly to your question. Like, here's a wonder is like, what grade level is this question? Another wonder from Elizabeth is, I'm wondering if the phrase, maybe it wasn't finished there. Hader and James got the same number of candies. Okay, so there's some info coming out here. We'll have to get that explanation from Anne in a moment. But I'm wondering, Kyle, about our estimate. Does anybody now, before I kind of give my wonder out, there's nothing's popping in the chat just yet. But my wonder about the estimate, Kyle, is that did we use all the candies?
Ooh, I love it. I'm willing to share that with you. And yes, we did use all the candies. So right now, look at this. It says,
that's all the candies right there.
Yeah. So Teresa's saying, are we to use the estimate to try to solve this? And I would encourage a student to use what they're feeling, right? So that might be helpful as a place to start when you start comparing. You go, okay, well, wait a second. Or you can go the other way and you could say, well, like, what if, if I look at some of this information, maybe I say one of these friends actually has a certain amount and I work based on that. And then I try to see whether my estimate fits, see how this all plays out. But really right now, one of the big pieces that we tried to do when we designed this problem was still keep it as far away from a one answer sort of deal as possible. Like right now, we're kind of forcing you to share with us a visual representation because none of you can actually give us the number of candies yet. So it's almost like forcing you into this path of proving to us what the relationship will look like. And John, when John had on the screen that sort of like a bar graph of all those estimates, like that was a beautiful visual to give us a sense of where all of those, there it is right there. John's got it up on his camera, like where all of those estimates were, except in our case, we actually don't have any quantities at the bottom. Like we can see that they're clumped together, but we don't actually know their values.
That's true. That's true.
And Elizabeth in the chat saying, I'm wondering if the phrase as much candy as can mean the amount ends up being more than Lucia or less than Lucia, depending on the fraction or number mentioned. Super interesting. I wonder if we can come back to that once we've shared some visuals to see if we can prove or disprove that, right? Like see if we can come up with some sort of statement, almost like a big idea around that language. Super cool. So I'm hoping
so what do we do?
Go ahead
right
there,
now,
John.
just to be clear for everybody's action right now is that right now we're asking you to solve this problem or come up with an answer. You're trying to show some sort of mathematical or visual representation or some thinking on a page. We've done this in the past where you are going to share that back to us. So every one of our episodes, we've asked you to do a little bit of thinking and then take a picture of that. We're going to do the same thing here. We're going to give you some time. So we'll probably need a few minutes here, Kyle, for everyone to kind of reread while we don't speak in their ears. But I'm going to put that link in the chat for you to do the joincage.com. If this is the first time you have joined us on that one, you're going to head over to joincage.com, put the code in that is on the screen. I'm going to put it in the chat. But from there, your job would then be to, I think you just go to guest, log in as a guest, put your name in, and then a button shows up and you just click upload, and then you just upload the picture of your work. All right, so we're gonna go silent here for a few minutes, and we're gonna come on back, and we're gonna talk about some of these solutions, have a good chat about this particular problem.
Beautiful. See you in a few minutes, my friends.
While you guys are doing the exercise, I'm gonna let you do the exercise and submit it. And the link is there. It's johnkh.com and SIP2234. And I just want to let you know that I'll make sure to ask John to give me the name of the app and the link of the app, and I'll make sure that it's included in the email that we send you tomorrow.
Okay,
Because I don't remember the app myself, but I'll make sure that John shares it with us.
Okay.
I just spent some time resolving this problem. I love
I'm doing that too.
Drawing it. I know. It's like every time I do it, I always have to go back, reread it, look at it. Go,
I'm not done yet, though. I'm not done yet.
I know. No rush. No rush,
All right,
my friends.
All right. Keep it going, folks. Keep it going. Think about this one. I'm looking for really nice solutions that show up here, and maybe like turn some mics on once we're ready here to do some thinking through this, and I would love to say do my thought process, because I think I took Kyle's hint a little bit about starting with our estimate and kind of working backwards a little bit. That's the way I'm thinking about this right now, but I'm not going to say any more. I'm going to turn my mic off. I'll see you in a few minutes.
And I will also mention, my friends, in the chat, Marcus said, I think it'd be nice to have Lucia's amount. And we've intentionally not given that amount because as soon as we do, it's like we just turn to calculating instead of visually representing. So here we're really pushing students to represent and show the relationship between these quantities in using fractional thinking. So it's kind of pulling you in kind of two directions here. We're using data, but we're also using and building our number sense as well. And yes, the class code is SIP2234. We're starting to see some graphical representations coming in. All right, now that we're seeing some of these solutions coming in, I'm wondering, do we have any brave souls who are willing to just give us some idea around what you were thinking as you were working? And maybe you're still working, that's completely fine. We're just kind of looking for someone who might be brave to sort of share, like, what was your thinking? Like, what did you do? What did you try to do? Where did you begin? And maybe we can go from there. Is there any brave soul out there? Let's see. No brave souls yet. We did get some solutions in, which is great. Let's see. All right, Nicole saying, I started with Lucia as 1 candy and Chin as 2 candies, which that sounds like such a great way to kind of make this accessible, right? So it's like, okay, well, I know twice as much. Well, twice as much as 1 is 2. Awesome. And then we can go from there. And then it said it didn't work for James. And I'm going to go on a limb here and say it didn't work for James because it was like 1.5 times, started like maybe getting you down the fraction path. And you might have been like, it's not as, maybe not as nice or as friendly, right?
Let me have a look here.
Super. And then says, then I change it to Lucia to be 2 and Chin to be 4. And then 1.5 says James would then be 3. Super cool. So you've got a lot of,
That's
you've
the
got
way I
a
did
lot.
it.
Yeah, super cool. Like a lot of different ways. Awesome stuff. Is there anybody who would like to, John, if you want to tend to the chat as well
I'm in the chat.
As well as if there's any other brave souls who'd like to share, that would be awesome as well. I'm going to pull up a couple of these solutions that have been submitted.
Interesting.
Coming in now.
Colton had an interesting comment. It sounds like he was applying some of the same strategies as we've mentioned here, but then he said he had totals that were then too high compared to his estimate, which is very interesting, right? So it's like he's doing some playing around. It says he had to redo it 4 times, so he's like playing around with the numbers to make sure the fractions, I think, work out. Now I don't know if Colton wants to turn on his mic and share, but I'm just guessing on some of the thinking that happens here, because that's some of the thinking that I did, was that I compared to my estimate, or actually I compared to the most common estimate, thinking about 25 was the most common estimate. And then I said, you know what, 25 is, I don't know if it's going to work here if we have these so many candies. So maybe 24 was a number that we could work here. But then all of a sudden it was like, oh, we're gonna get too high of numbers. Maybe Colton had a similar experience.
I'm here. I'm Colton,
Oh,
except I'm
sorry.
not Colton.
Got it.
I'm actually Rebecca. I sent in my thing, Rebecca.
You're fake Colton. I love it.
On my device, so I keep coming up as Colton in all the meetings I go to. Anyway, yeah, so I started with 6. I started with Lucia, again, figuring that was kind of a good jumping off comparison, like base almost. Yep. I tried 6 and that was way too high. I didn't even finish. I got as far as James and realized it's way too high. So then I went to trying 4, and even that was a little too high. I think it was up in the 30s. I forget. I didn't bother working it out exactly. And then I tried 3, but that got really messy with the fact that there was a lot of thirds, and actually 3 would have been good for thirds, but not on the part I'm trying to do. So I went with the higher every time. So every time it said, so for example, one was 1.5, let me see. So James collected 1.5 times what Lucia did. So I had 3 for Lucia. So then I was trying to do 1.5 times 3. It gave me 4.5. Wait a minute, James. So whenever I had a choice between, say, 4 and 5, for example, I would go with the higher one of the 2. And that meant, but then my total was, again, I forget exactly, over 30 anyway. And I'm quite convinced there was only low 20s. My estimate was 22, but I could go as high as maybe 26, not 30, I didn't think. So then
I love how like you're like committed to that estimate.
Yeah. So then I went with all the lower of the options and went through it again, or almost everyone. I went with the lower of the 2. I think there was one exception. I can't recall now because I scribbled with pen, so I shouldn't have done that. I tell my students not to do that, and I did it.
Super cool. Well, I'm wondering as well, like, so such a cool process there. I'm going to move these out to the side for a second. And if I look at this representation, I'm wondering, can we get any feedback from the group here? If a student was to represent in this way with these bars here, notice that I haven't, like, again, we haven't pre-taught students how to do a bar graph or how to, do this quote unquote officially. We've asked students to try their best to represent this visually, and we're going to try to help them with trying to add details to it after when they consolidate. But when you look at this, I'm wondering, like, do you feel good about the relationship between the bars? Like, let's who cares what Lucia, what her number of candies is, or what Chin's number of candies is. When you look at the relationship, does this feel pretty good to you? If so, why? And if maybe not, or if there was something you would change, I'm curious about that too. What are your thoughts on that, my friends? And I'm trying my best not to block all of the...
You asked for a graphical representation to compare the quantity, but you didn't ask for the actual numbers.
Nope.
And so I decided to make a graph instead.
I love it. I love it. So you're feeling pretty good about this, right? It looks like Michelle says relationships look right. If I go through this, I might ask this student to kind of prove to me or to try to help me understand why these relationships work right. And I look at them or look correct. And I say, well, Chin is twice. Can I fit 2 of Lucia's bars in? Yeah, that looks pretty good. James is 1.5 times. So if I took 1 of Lucia and then another half and I placed it on top, that looks pretty good too. And actually, I'm most curious about this. I don't know if anybody noticed this, but like, look at this. And when we talk about Savannah and how Savannah, I believe Savannah had collected about 1/3 of James, you can almost see this partitioning of James's bar into thirds. So to me, this is exactly what I would expect many students to do, is something like this. And this is exactly what we're hoping for. And some students may have done what we just heard on the mic a second ago with like, hey, let's make Lucia 3. Let's see what happens. Like, let's see what our total is. But keep in mind, our estimates are only that, right? Like, we don't know for certain yet, which is completely fine. So I'm super impressed. Rebecca's saying Cuisenaire rods might be helpful. Absolutely. They would be super helpful. John, do you, if you still have Braining Camp open, do you mind flipping into the relational rods, or I don't know?
I've got kind of a solution modeled out here without, not relational rods, but with the stacking cubes.
Yeah, let's see what you got there. Go ahead and
let's see. I was modeling.
I'll remove
it
my
over
spotlight there. And we'll spotlight yours.
Let me put this. Here we go. So a little bit of building here. It's a similar thing. Actually, this is as I tried to go in blind on this question here, not thinking about the answer, and similar representation to some of the folks. I think I forget who I started with. Like you, I kind of already mentioned this, but I looked at like, hey, I wonder if our estimates were pretty close. Like a lot of people said 25. So then I said, hey, 25, I don't think is going to work. We got a lot of thirds and quarters or 3/4 and halves and doubling. And so we thought, well, maybe let's go with an even number. So I picked 24. So I put 24 blocks up on the screen. And then I said, you know what, maybe 1. Like, I think it was, who was in the chat that first said they started with 1 for Lucia. And I did the same thing. I was like, if that's 1, then we have, I think Chin has double that. And so then there's 2, but then we quickly realized that it wasn't going to work with James. So then we doubled Lucia's to 2 and then kept going with that. And sort of that the linking cubes were a nice way to, like, you can see here the doubling, like, or when you say like there's 2 of those and it's like I circled 2, like there's 1 of those and 1 of those. That's 2 Lucias. But then over here in black, I've circled, remember it was 1.5. So notice in black here's 1 and then a half. In like a purple was a box and a half of a box. That's the same as Lucia's. And then it was nice to say, like, that same partitioning happened with comparing James to Savannah, for Savannah having a third. So it's like, let's section James off into thirds here. And then we've got Marquise, 1 1/3 of James, which was nice, is already a third. So it's like 1 1/3. There's 1/3 right there. And then Savannah having 3 times, or sorry, Hader having 3 times the amount of Savannah. So it's like, clearly you can count these. But yeah, I can flip on the relational rods here too. I don't want to like make that go away yet. So over on Braining Camp, they've got lots of tools here. I did the cubes. You already saw the number lines. There's Cuisenaire rods here. And so you can build it out there. Like if I go with, I believe that being, if they say that's 1, then that's 2. And then there's a doubling right here. And then what do we have? We have, say, thirds right here. And then we go back to 1. And then we have, say, the doubling again. And then we have a third again. There we go. That's the same one on your screen there, Kyle.
Yep. Yeah. Pretty slick stuff we've got going there. So Braining Camp's got an amazing tool. I think one of your bars may be mixed up there, John, but no big thing. I know you're just modeling.
Oh,
no, I just like,
switch these around.
Just like I do every single week, I manage to mix at least one of them up. But yeah, like the reason I pulled this one next, John, was because this one reminded me of your concrete representation. I know it wasn't concrete because you were using a virtual manipulative, but just this idea that, again, we're trying to leverage students' understanding. And here it's like the fractional relationships here. And then, and only then do we really need to worry about tossing some numbers in, right? Like if Lucia is 2, then Chin is 4, James is 3, Savannah's 1, Marquis is 4, Hader is 3. You get the idea here. And there's so many different ways and different representations here. Here's another one I saw come in. You're going to see all kinds of varying approaches, and it gives you some insider information on what prior knowledge students have bringing with them to the table. Like, so obviously this student has some prior knowledge with graphing. That's really important for us to know. Like, I just think about all the times that I used to teach a lesson. I'd spend a whole lesson on teaching a graph, let's say. And meanwhile, there's some students that already know, or almost either intuitively know, or they've seen it somewhere, and they put one together pretty well. So it's like, let's let them do this work. And then we can start kind of building around that and kind of pushing the students a little bit further. I just want to show some that students might use. This is a very neat student here using relational rods, like actual relational rods. So you can see that comparison. Here's another one, like a student using more, again, kind of similar to what you did, John, except here they're just using X's, like almost like a pictograph.
Yep. I like it.
And here's another one. Again, we see sort of like a similar relationship to what you had shared, but notice the partitions are a little bit different. The way they've partitioned is, no, the partitions are the same. My apologies. I thought this one was one. But you get this idea of where students are and what they understand about this particular problem. And for us, there's nothing better than giving them the opportunity to kind of productively struggle through this. And the beauty is, when we come out of this particular problem, we don't actually give them the answer yet. We send them on their way by adding just a little caveat to this problem. We're not going to have you do this one today, but just to give you a sense of where you'd send students off to next, after we consolidate and get this understanding of the relationship between the different candy quantities, we then send them on their way for a consolidation prompt where we say her dad collected about 1/3 of the amount of candy that Lucia collected, while her mom collected about 5 times the amount of candy that her dad had collected. And we give them this opportunity so that they can take what we've done in the consolidation and kind of move themselves forward and essentially kind of build on this idea of graphing, of showing relationships with data, and being able to essentially read graphs as they're working through this particular problem.
Nice stuff there. And I really like how, in particular, Kyle, this problem, I think we mentioned this before, but this problem did not give us the total number, because think about the types of, the amount of solutions that you could have come out of this. Like you showed one where the kid drew a graph, but I just quickly on my screen, doubled the amount of quantities I started with, and all the fractions are going to remain proportional, right? So it's like I had counted out a certain amount of counties, but if I double everything, I've got all of a sudden the same proportions laid out, which means all the same conditions in the original expression or the original statement are going to be accurate, but now I've just got more candies. And then it could be doubling that again. It's like, hey, how many can you come up with? And then the nice thing about that is you're coming up with a whole bunch of sets of solutions, and then you can probably put a condition on it one more time, and then that can pinpoint exactly how many candies are in the bag.
Yep, super cool. So when we go through there, so this consolidation prompts, the students then get this opportunity in order to explore, as we had mentioned, again, only comparing. So what we're hoping students would be able to come back to us with, maybe not with all the details on a graph, but starting to form this idea of what a bar graph might look like and sound like. Again, we don't know how many Lucia collected, and her mom collected 5 times the amount of candy that her dad collected, but her dad collected 1/3 the amount of candy that Lucia collected. So really, it doesn't matter what the value of Lucia's candy collected is. What we really care about is the relationship. So again, if we use that and we go, okay, well, if her dad only collected 1/3, well, we're going to have to think of Lucia's candy like partitioned into thirds, right? So here we can see the thirds and we go, well, her dad must have collected that much. So if she collected 3, dad collected 1. She collected 30, dad collected 10. And mom collected about 5 times the amount of candy that her dad collected. So I look at dads and I go, 5 times the amount. All right, well, we know what that means. Like, it's not just one, it's not the same amount. It's not double, it's not triple or quadruple. It's actually 5 times the amount. We can then see this visual to get the perspective of how much relationally each person in the family collected. We can then ask about how much more candy did Lucia's mom collect if you really want to push them. So you think about this, you go, holy smokes, how are we going to do that? We don't know the amount of candy that Lucia's mom collected. I'm wondering, I'm going to put it to you folks in the chat, and feel free if you want to raise a digital hand to share about how much more candy did Lucia's mom collect than Lucia? Whew. Based on what we know.
Good one.
This is a great, great question. So I'm going to give you a moment to think about that. And then we're going to set the stage for where this unit progresses to, because there's one other idea I really want us to get to. As you know, we're constantly trying to get as much in there as possible, but we also don't want to rush. We want to slow down and give you some thinking time as well. Now, something that I'm wondering about. All right, so we're seeing some shared in the chat. Like, I was going to ask, and if nobody was responding, I was going to start asking and say something like, well, what if, like, is it double? Is it more than double? Is it less than double? Like, that would be where I'd start in the classroom, right? I'd be like, okay, so like, let's look at, where is it? Right there, bang.
They're all coming in. Yeah.
Let's look at moms. Like, double would be up here. So if a student thinks it's double or more than double, then we know we've got an issue that we're going to have to try to sort out. We're going to have to ask some more questions. But if students are like, well, it's more than Lucia, but it's less than double, that's a good start. And then the question becomes like, how can I get more precise than that? John, what are people sharing in the chat here?
Just a lot of answers. So a lot of 2/3. We've also got one that's 1 2/3. So there's a few, actually there's 3 or 4 1 2/3 and many 2/3. So Kyle, there's we're in a kind of a crossroads right here. Where is it 1 2/3 or 2/3 more? It's like almost like 1 2/3 times the amount versus 2/3 more than the amount. And both are, I think, correct in a sense of the way you describe it.
And this is something too, it goes all the way back to Elizabeth. Elizabeth's a good friend of mine, a fellow colleague in my district, and also on the committee for OAME 2022, which we're having here in Windsor next year. So Elizabeth mentioned earlier about language, right? And like, could it mean more than one thing? And I would argue that this is where the language becomes really important, because what we're dealing with, John, what you've highlighted is this difference between additive thinking and multiplicative thinking, or what we like to call absolute thinking and relative thinking. So if we're thinking additively, we're thinking of like how many more or how many less. And when we're thinking multiplicatively, we're thinking like how many times more, right? Which is, and it's funny because we could say how many times more, but it's still times if we're thinking less. It's just, it would be a fractional amount, right? So that's kind of a mind-blowing one. And we talk about that in our course, The Concept Holding Your Students Back. We go so deep in there. It means, I don't know, for me, these last 18 months have really been focused around that idea. And it is something that we don't really get out of a traditional K-12 curriculum. Like, it just kind of goes under the radar, right?
It's definitely a discussion I have with grade 9s, grade 10s, grade 11s about like this, like it times more or more, like more? It's like we were doing a volume problem a couple weeks ago. Actually, it was more than a couple weeks ago. It was back before Christmas holidays, before we were off, and the volume problem was like, well, how many times bigger is this aquarium than that aquarium, versus how much more can it hold than this other aquarium? And kids, it's still, in grade 9 and grade 10, still trying to wrap their minds around the differences in just language to relate to multiplicative or additive.
Yeah, and I'm going to go, and it's great because Michelle and Annabelle in the chat kind of have this, like, two views, right, or two perspectives. And I'm going to say that they're both correct. They're articulating correctly. And it's the difference between the additive and the multiplicative. So when we hear someone say that the mom has 2/3 more, we're referencing this idea of like additive, like 2/3 more than the original. So we're just adding those 2/3 on. I can clearly see that right here. I see, here's what Lucia has. She has 2/3 more than Lucia has. But then we look at 5/3 as much as Lucia. When we say 5/3 as much, then it's like we're now like linking it. It's like we're now talking about that relationship, that relative language. And we can see, like, here's 3/3. Mom has 1, 2, 3, 4, 5/3 of what Lucia has, which then tells us how much does Lucia have compared to her mom. She has 3/5, because the mom's is now the whole. We're now like, this is the reciprocal thinking. We're going, wait a second. Now mom has the amount we're comparing to. So here's this amount. Where is it? Over here? Bang.
Yes.
Over there. There it is. This amount right there is the whole. And we've chopped it into fifths. And now we're talking about Lucia's compared to her mom. So holy smokes.
Yeah, like it's
thinking here.
It's pretty nice the way that you have structured, the way we structured this problem to do with students, to bring out, think about the overall expectations in your course that you've just talked about, right? So you're doing proportional thinking, we're doing comparison, we're doing additing. You can bring in, like, you've added fractions, you're looking at comparing fractions, but we did all of this with data management, right? Like we're looking at graphs. We did some estimates on looking at our number line and thinking about making bar graphs and comparing numbers on a bar graph. You said it right at the top of the episode, or right at the top of the session, Kyle, is that data management is a great way to bring in so many other aspects, especially number sense, into your course, which is hinting on this spiraling idea of picking tasks that you can hit more than one expectation from in your course. So that's something that we do on a regular basis in our courses, in say my grade 9 course, grade 10 course, Kyle, when you were teaching grade 9 and 10, but definitely spiraling in this huge idea of mixing in different expectations on the same task.
Yeah, absolutely. And John, at this point too, I think it's probably a worthwhile endeavor to bring up the unit.
Sure.
So we'll share this link at the end of the session, and it'll come in the links that you'll get after the session. I think that email will come tomorrow from Michelle. But when you look, like we just did day 1, right? We did our notice and wonder in the Spark tab. We did our sense making. Here's that context. Again, I would always articulate, you want to like verbally share this context. It's a very long story problem. And then we had our official prompt, which we shared. And after, we gave students this opportunity to kind of, extend their thinking a little bit and kind of build on what we were working on in day number 1. Now, on day number 2, when we go over to day number 2, we start off with a math talk, and it's all about trying to promote this idea of relational thinking, right, John? Like you were saying, this multiplicative comparison. So we give them some scenarios that are not related to the context, like 25 grams of gold and 100 grams of gold. And we ask them to compare 6 feet and 8 feet. And we try to get them thinking in this relational sort of way. And then on day 2, we extend it and we actually share how many candies Lucia had. And I think I'm realizing, I think I may have incorrectly told you in the bag was only what Lucia had. It wasn't the total. So now I'm realizing why everyone was mad about their estimates. So my apologies for that. That was Lucia's
I thought that was
candies.
the total.
Yeah, I know. I'm realizing that now as I said it. I'm like, oh yeah, I think I told them that backwards. My apologies.
This is why we all had low numbers.
Yes, exactly. Which again, not the point of that activity.
No,
so
exactly.
completely fine. But once we reveal that with the class, and we share, we let them see how many she actually had 43 candies in that bag. So nobody guessed it. And nobody was even in the right range. There was 43 in that bag. It doesn't seem that way, but that's how many were in there. And the video sort of skips. Yeah, but and that's fine, right? It's more building our spatial reasoning. But then we ask them to go back and we ask them to approximate how many candies did each of her friends collect. So this gives you an opportunity to take this model that you had originally created, like maybe yours looks like this is the one that I did, John. Remember I was saying, I'm like, I had a lot of fun redoing this myself, but this is the one I did. And, I just tried to do it quickly, like a student would do it. No rulers or anything. I did use some partitions and things.
Yeah.
So now it's like, if Lucia collected 43, it's like, what else do I know here? And I can use all kinds of thinking. I can use multiplicative thinking. I could use additive thinking, right? Like some students might add 43 twice here and go, okay, well, if this is 43 and this is 43, that's going to be 86 total. Okay. Right. Oh, that's going to be 86 total. I don't even have to do a whole lot because I knew these were the same. And students work through the problem in this way.
Yeah, that's a nice way to, I was just going to say like when I had solved it, I think with, I think it was Rebecca, was that like, I think it was Rebecca, don't quote me, but this starting with the estimate and then trying to work backwards of like stake with 24. And then I picked 1 and then started to like double. Whereas you were like, let me just say that's 1, but I don't know exactly how many it's going to be. And then you can partition 1 into thirds. Whereas I was thinking along with probably some other folks being like, well, I can't have a third of a candy, right? So I don't want to like write a third of a candy instead of thinking like, well, maybe the third is the 1. And totally. And that's which what you did here.
Totally, absolutely. And this, you can take this unit as well. I want to make sure, some people were asking about what grade level. I'm going to argue you could do this with students in grade 3. You may not push as hard on the multiplicative comparison aspect of it, right? So again, like you get to kind of massage this. What I would argue though is just make sure, like I always ask educators to be cautious that we don't water things down too much. Like we want to make sure that we find enough push for students, but keep the floor low enough, but that ceiling high enough. So trying to push them, but not overwhelming. So it's like finding that nice kind of flow for your students to work through. And in this particular problem, once students actually consolidate and we realize how many students are going to share, like how many candies each of the friends have, the question we then have is we ask them to update or recreate a bar graph. Like these are the actual quantities. Remember, you folks caught this. Someone in the chat caught it and said, it does say about. So like even the fractional amounts actually weren't exact. So she had 43, Chin has 84, even though based on the fractional amounts, Chin would have 86. So then we go, okay, well, this is the real quantities. We gave you some approximates. Now I want you to update your graph. So notice how like we're taking this original graph, which is kind of like sloppy looking, right? Like it's not super beautiful by any means. It's like a rough draft. When I look at mine here, right? We're taking this and we're trying to help students slowly get their graphs into more of a, we'll say like more of a standard form. And we're trying to help them with their structure in order to emerge this idea of graphing. So with this particular problem, there's lots and lots of awesomeness. This is the approximation students would have came up with, and then the actual quantities. And then
Are-
basically students are, oh, sorry. Yeah.
Are you trying to share some? Yeah, you're sharing.
Yeah, I was going to say these are, what they would have came up with when they actually used, the quantity for Lucia and the quantity for each. And then we give them the actual quantities for this opportunity to update their bar graphs and kind of improve their bar graph, almost like a good copy of it. Mm-hmm. And that is all of day 2. But day 3 is even better, because in day 3, we actually ask the students and we ask them what they notice and wonder now. And then this is the part that I think is so great and really ties things together for data management. We ask the students then, we say, well, if they should all receive the same amount, like imagine you're at the birthday party, you do this scavenger hunt. Maybe somebody in the chat's brave enough to share that they've done this for their own child or someone in their family. And then you're at a party where one student has 80 candies and another child has 20 candies. There's going to be a problem, right? So we ask them, like, how are we going to ensure that everyone gets the same amount if all those candies we had, like this is all the candy that we have, how are we going to help them to redistribute this candy? And I'm going to pose that question to you because I'm curious, what would you do if you were a student and you're there and you're like, well, Lucia has 43, Chin has 84, Savannah only has 22. And before we leave the party, we want to make sure that everybody has the same amount, but this is all the candy we have. There's like no more hiding in the house, and the parents aren't going to give them any of your, like the dad and the mom already ate theirs. So we're not going to consider that. But here I'm wondering, take a moment, don't share it. If you already did, great. But if you haven't shared yet, don't hit enter yet. I want you to think about this. Mm-hmm. What are we asking the students to do here when we take all this data and we say, I want to make sure everybody has the same amount before we leave. I'm going to pause, give you some think time, and then we'll give you an opportunity to share out. So don't hit enter yet, but you can raise your digital hand if you'd like, and then we will share out as a group. All right. I'm wondering, my friends, do we have any brave souls who are willing to share their thinking here? Like, what are we trying to get at here? And students wouldn't know this is happening. Like, you have to keep in mind,
they're not going to know the name.
Yeah, they're not going to know what this is that we're asking them to do, but they're going to do it. Like, every student would do what we're asking. We're like, listen, here's all the candy. Everybody's got to have the same amount. What the heck are we asking you to do? And I'm curious if anyone's brave, if they want to like share some of their thinking here. John, I'm going to let you kind of take a look because my screen I can't see.
We've only got a couple responses in the chat right now, but I'm wondering if anybody wants that to turn on their mics and open up. Yeah, Ness is like, nope. If you got them, you keep them.
I love it. Teresa, what's Teresa saying there?
I just said add them all up, divide by 6. No.
Yeah. That's what we're leaning towards on here. That's exactly what we're doing, right? We're trying to find the mean of this. This is the number that everyone's going to take home for sure. That one came in from Teresa just put it in, I think twice there, but we saw that. But I was wondering if anybody wanted to elaborate on how a kid might do this if they didn't realize, like we being teachers, just add them all up, divide by 6 to get the average.
A little kid might say, okay, Chin's got 84. He's got too many.
Right.
He should give me some, give some to Chia. Like they would disperse them.
I love it. I love it.
Exactly.
So it's like if we were looking at, if we looked at our approximations, let's say we weren't paying attention to the actual quantities, it's like, I'm just gonna like move these around, right? Like I'm gonna like be like, Chin, you have too many, Marquis, you have too many. Let's see what happens, right? So, I mean, I could take these and go, you know what? I've got kind of, you know, some things to think about in the top here, but basically it's like, here, let's move that over there. Let's maybe move that over there. Let's, this isn't gonna work.
Still too much.
Still too much. What can I do now? Maybe I could
now kids would
chop
just
that
take
up.
Exactly. So kids are going to fair share here, right? So it's like dump them all. What naturally would happen if you were actually at a party and had to do this, you dump them all in the middle and you go boop, 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 and divvy them all up. But instead of saying, okay, you give me a couple, you give me a couple, but that's what Kyle's doing. You give me a couple here. Let's divide all these up.
Yeah, totally. So that's one way you might see students do this. But really what you've done is you've essentially gotten students to emerge this idea of the mean, right? So, I mean, if we did this, and here's like another view. This is what the actual quantities, right? Lucia, Chin, James, these are the actual quantities we had. And if you kind of look at it, it's like, okay, I'm within here. Like I know it's going to be more than 22, less than 85. And I could, again, just kind of do a little bit of this, just distributing here. And we get closer and closer. And students are obviously going to do this in like a very mangled sort of way, right? Like they're not going to do it nearly as organized as this, but ultimately your mean ends up becoming 60 candies. And I like, just to share what some students might do, like they're going to take this and they're going to maybe do it symbolically. Like you can see up on the screen, they're going to like, just take all this and they're going to try to like fair share it. Maybe they do it all into the pile, just like John said, maybe not. Maybe some students are going to like share numbers. My daughter did this when she was calculating the mean. She's in grade 3 and she basically like just took some from these big numbers and added them to the small numbers. And then she adjusted. And it was like, it was fascinating to see, because I'm like, I had no idea that that's what a student would do. Because I was just told to add them all up and divide by, you know, by how many people there are. So there's so many strategies that can emerge here. And the whole goal, like the big idea we want students to take away when they do problems like this, is we want them to walk away thinking the mean is the great equalizer, right? Like if you think about that, the mean is the great equalizer. It's like, I went to the party, everybody had different amounts of candies. What did we do? We tried to make it equal for everybody, right? And that's what we've done here in these very, very different ways and different approaches.
Yeah, and it's such a great an activity to approach it from that way, to instead of just saying the mean is you add them all up, divide by how many there are, instead of giving them an actual context so that they can wrap their mind about what the mean actually can represent.
Yeah, absolutely. So with that, my friends, we're going to start wrapping things up here. We are notorious for going long. So I think starting with a few minutes to go is actually probably the best we've ever done so far.
I think so.
Up on the screen, you see the 4-day unit. This is a 4-day unit. On the 4th day, it's just more of a show your growth day, which is like an assessment day, where you give students another scenario related to this big idea of data management, graphing, the mean, and we give them opportunities to kind of build on this. And we're going to definitely share this out with you. I'll put it in the chat in just a moment here. But John, let's get ourselves.
Yeah. Now, before we do that, I'm going to grab that link, put it in our email to Michelle. But one thing I wanted to say about the tasks is the question that does come up a lot, and it did come up here in our chat today about the grade level on our tasks. We on our tasks page that we'll throw in the which you can find through the link that Kyle just put in. But on the task page, we do not specifically say what grade level each of the tasks are for the reason that we shared here today, is that you can take a lot of these tasks and use them in your class and change them a little bit, right? So it's like we've done it by topic and strand. So like, for example, if you're teaching grade 8, you might be like, okay, I know circles are in my in my field, let me go look at what the circles are. Or if I'm teaching division, I'm gonna go click division, see if that task is relevant. So we want people to actually like read through the tasks to see if it would be applicable, how they could apply it to their class, instead of saying, hey, that's a grade 3 problem or that's a grade 5 problem, is because we know that we can use this task in grade 9. That task that we just did is in grade 9 for sure. But Kyle also just said, hey, we could do this in a grade 3 class. So that's the reason why we don't put the grade levels on it. All right, let's start wrapping up here, Kyle, and heading back to our usual, see if we hit the nail on the head here today.
Yeah, awesome. Let's have a look at that. I put a link in the chat for Annabelle. If you're looking for work with algebra, definitely check that out. Yeah, let's hold ourselves accountable here, John. Do you friends let us know in the chat by putting a heck yes if you feel like you had your curiosity sparked. And again, we talked and tried to unpack and go a little deeper with this idea of withholding information. We withheld the quantities. I even lied to you and said that all the candy was in the bag. Yeah. Which, hey, you can use that if you need that. If you need to lie in order to spark curiosity, do what you need to do. But hopefully, you felt that there was like some intrigue. There was something there to engage you here and get your learners to lean in. John, what are they saying in the chat? People feeling good?
Oh yeah, there's a lot of yeses coming in. And the other thing that we wanted to help you out here with is specifically about data management. And we didn't talk specifically about probability, but that being the strand, we wanted to help you wrap your head around how you can do this conceptually through tasks, but also bigger idea is how you can tie in other strands into data management. We hope you got a sense out of that. Give us a yes in the chat if we hit that one. Yes, we got a couple of yeses coming in here.
Awesome. And then finally, I'm hoping, and this is through all of our series here, hopefully you're feeling that you're strengthening your relationship with mathematics, building that productive struggle, maybe looking at math a little bit differently. Like, for example, if you never really thought of data management as more than just creating boring bar graphs, I'm hoping that you're seeing that it's like, wow, it can be more than that. We can bring number sense in. We can build our fractional understanding by comparing and using relative thinking throughout data management. Hopefully you feel good about that. John, what are they saying? Heck yes?
There's some yeses, and math is fun from Teresa.
All right, math is
awesome
fun
stuff. One last thing we want you guys to do before you take off for the evening is something that we always throw in the chat at the end, is to reflect on the session itself. We said 3 things we were hoping to get, but maybe you pulled something else. So what is your big takeaway in the chat? Go ahead and throw that in the chat, please. What was a big takeaway from this particular session? And Kyle, are we going to give away? Like, I know that the workshop started this week. We could sneak somebody else in though.
Yeah, you want to do that? I put the academy there, but yeah,
the
workshop we just started.
Your picture says the workshop, so that's why I thought the workshop. But
does it?
Yeah, but we could do the academy for sure. So one or the other.
Beauty. Well, you know what? We're going to let them pick. If they would rather the academy, they can let us know, or if they'd rather the workshop. So once you select, we'll have you contact us after, and then yeah, you let us know. We'll toss either one your way. We are going to give you a little bit of time for some big takeaways. We're going to pause and we're going to turn over to Michel so that he can wrap things up. And Michel, you can be our selector based on reflections. I love that we're seeing things like we don't always need the answer. Graphic representation is good, and that is really big. Math tasks are able to apply to any grade if you put your thinking cap on. Awesome.
All right, Michelle, take it away, and then we'll come back and choose.
Okay, guys, thanks so much. A fantastic session again, really. I'm running out of superlatives, so I don't know what I'm going to say every time, but fantastic session. We had a smaller group. I love that. Lots of participation. I love the way everybody is sharing in the chat box, answering each other's question and all of that. There was a lot of humor also going on. I love the way Ness and Teresa confronted their vision of capitalism and socialism. Ness said, keep it let the strongest keep it all, and Teresa said no, let's divide it, and it's all interesting, all really, really good. So excellent. And just I want to let you know, many of you have asked about links, and I'm going to gather all the links this evening, and we will send an email to everyone tomorrow with all the links, so you don't have to worry. I'm actually going to quickly share my screen to show you that. Where did I lose my? Hold on a second. Oh, here it is. Just a quick second, guys. Sorry about that. I'm a little bit lost here. Just okay. So you're gonna get tomorrow, obviously, the links that we have shared today. You're gonna get also an evaluation form. No, you have asked me if I wanted to select someone. I was thinking, I mean, some of you were very brave today. Who was very brave? I put a few notes. Teresa was very brave. Annabelle, Michelle also participated. I think maybe Rebecca, I think she's also known as Colton or something like that.
We do have a Rebecca. I changed Rebecca's name in the settings. I renamed Rebecca.
Yeah, so I don't know, if you ask me, maybe we can give it to Rebecca. She was a very
Michelle.
active participant. I don't know if she's still in the room, but hopefully she is.
She probably cool. We got a big takeaway from Rebecca here, revisiting, spiraling, and expanding the application of data management to other areas. So Rebecca, you have won the prize selected by Michelle, and we want you to email us. Head on over, you can makemathmoments.com, and there's a little blue button in the bottom corner. If you click that, that email will come to us. Just say, or maybe you get our emails and you can just respond to any of them. And then, hey, I'm the Rebecca that won today in this session, and we'll reach out to you and hook you up.
I love it. I love it, my friends. It's been fantastic as per usual. Thanks so much for hanging out with us, everybody. And yeah, there's that blue button. If you see up on my screen there,
it's a little in the bottom right corner.
Bottom right corner. Give it a click and let us know. And everybody else, go check out some of those units. Give them a shot. And we love hearing about how they go when you use them with students. So let us know, and we will see you all next
week,
Thursday.
Next week, exactly.
All right, everybody.
2 more to go. So I'll see you all next week, February 11. And then we have one more left on the 18th. It's going to be the last webinar of this season, actually. So thanks so much, everybody. Thanks for your participation.
Thanks. Take care, everybody. Enjoy your evening.
Okay. Bye-bye. Thank you.
See you later.
Take care, everybody.